Thanks, Dan. I think this is quite an interesting last question, because you just said 13 marks here. And I think these 13 marks hinge on doing one thing. And if you do that one thing, if you notice it, there are 13 easy marks. If you don't notice it, there are 13 really difficult marks. And it's a little bit unfair where so much hinges on one particular thing to notice. And that is that this is a quadratic that's been transformed. And the easy way of thinking about transformations of quadratics, it's all about completing the square. If we notice this is about completing the square, it's easy. If we don't, then we're just kind of stumbling around in the dark, really. So before we do anything else, before we think about, this is all about the transformations here. The curve x squared has been transformed by these three things, and you need to describe what the transformations are that take it from x squared to that graph there. And we can kind of see it's going to be a translation that way, and then a translation downwards, and then a stretch. But we need to describe them in more detail. Right, this is it. It's all about completing the square. If we do it, then it's going to be all right. F of x is k times x squared plus 4x. I want to rewrite that so it looks like a completed square. X squared plus 4x, well, we get that by multiplying the bracket x plus 2 by itself, x plus 2 squared. So this is k lots of x plus 2 squared. However, if it was just x plus 2 squared, that would give us x squared plus 4x plus 4. We'd have 4 too many. We don't want an extra 4 hanging around in that bracket. So that's it. So that's what we need to get it to look like. If we can get it to look like that, it's now relatively straightforward, because now we're even told that the transformations happen in this order, and they're all there just to be read off what's going on. So our transformations are, firstly, the translation where it's x plus 2 inside that bracket. So it's a translation 2 units in the negative x direction. So that's the first one. Our next translation, having moved it 2 across, we've got this minus 4 hanging around down here. So it was then a translation of 4 units downwards. And then finally, k comes into it, because the whole thing, once all that had happened, was multiplied by k. So then it is a stretch, scale factor k, in parallel to the y-axis. That's the best way to say it, isn't it? I don't know if you remember it, but in the answer booklet, you were given loads of space for this. This is the answer booklet here. You were given a box down there, and then the box continued for half a page over there. I didn't use any of that. I did it, the whole thing, in 4 lines down there. And that's the thing, that if you spotted it was about going with the complete square and working from there, then it's really straightforward. If not, you're just kind of guessing what you're doing.
I just fiddled around with it for a while.
Did you get there, Harry?
Yeah, I got there eventually.
Okay.
But last
Now,
question.
find the range in terms of k. Well, actually, what we're saying in this bit, it may be helpful to extend what we did in the first bit a little bit. We're saying here that this function f of x is k times x plus 2 all squared minus 4 times k. If you multiply out the bracket, that's now what it looks like. And this is, again, it's all about, if you've got it in the complete square form, it's easy. Go back to core 1, and one of the things we learnt about quadratics when we did computing the square was that if you write it in that form, then the minimum point is always at the x value that makes that 0. So in this case, minus 2. And the y coordinate of the minimum point is whatever's hanging around over here. And so that means that this point in our graph here is the point -2 minus 4k. And this function is always bigger than or equal to minus 4k. So the answer to the question, what is the range of the function? F of x is greater than or equal to minus 4k. That's it. And part 3, it is given that there are 3 distinct values which satisfy the equation the modulus of f of x is 20. Find the value of k and determine exactly the 3 values. Well, that's saying I did a little sketch of this to help me visualise exactly what was going on. The modulus of this graph, well, it's a graph that, how will I draw it? The modulus would look like that, wouldn't it? Because the original graph went down there, so the modulus would bounce on the x-axis. And if it's got exactly 3 solutions when it's equal to 20, that means this horizontal line like that is the line y equals 20. So that's at 20. Now hang on, the first bit of this then is quite straightforward. If that point there, I said on the original graph, the point down here was at -2 minus 4k. So once that's been reflected up, once we've taken the modulus of that, this point here, that point is the point -2, 4k. And if it's got exactly 3 solutions, that's at 20. So 4k equals 20. All along, k was equal to 5. If k is equal to 5, what do we know then? The original graph, the original function was 5 lots of x squared plus 4x. So the original function we were dealing with was 5x squared plus 20x. So it's, what, 5x and 1, that tries it like this, x plus 4, yeah, there we go, and the middle value, I'm not sure that was necessary actually, that tells us that these values are 0 and this is -4, isn't it, we've now got, and so this point here is halfway between them, we already knew it. That point there is at -2. So one root is x equals -2. We now need to find the other 2 roots. That's one solution there. We need to find these 2 points here. They're not -4 and 0. They're more negative than -4 and more positive than 0. They are the points where the original graph equals 20. We can ignore the middle bump now.
Is x equals 0?
So the other points, no. X equals 0 is that point there. It's 0 at x equals 0. We want to find when it's equal to 20. We now need to know the other 2 points are at the point where f of x equals 20. In other words, 5x squared plus 20x is equal to 20. Let me divide through by 5 and take everything to one side. I've got x squared plus 4x minus 4 is 0. That kind of feels like we could factorise it, but we really can't. So what do we do if we can't factorise it? We use the quadratic formula, or we complete the square. We do one of the 2. Let's do the formula. X is minus b plus or minus the square root of b squared minus 4ac all over 2a. Minus 4 plus or minus root 32 over 2. We're just about there. Minus 4 plus or minus root 32, that is 2 lots of 16, so that's 4 root 2 over 2. So we've got the other two roots are minus 2 root 2 and minus 2 plus 2 root 2. And there they are. We already had x equals minus 2 equal. That's it. Stop the clock, anyway.
Oh, yeah.